This video will be on section 4.1, function composition. So the two things we'll be doing here, we'll talk about function composition of formulas, and then the last topic we will, after we know what function composition means, we'll be able to break it apart. But right now that doesn't make sense. So we'll talk more about that when we get there. All right, so function composition of formulas. We begin by defining the notation for composition of functions. It says let f of x and g of x be two functions. Then the function f composed of g, written as f circled g of x. So it's like an open circle. It's not a multiplication sign, this is the composition sign. Or symbol, whatever you want to call it. Is the function gotten by first plugging x into g of x and then plugging that into f of x. One thing I like to go ahead and write down almost immediately is that the notation doesn't really tell you what to do, so we often rewrite it. And you'll see when I work through the problems, I'm going to rewrite it like this every time. If we want to plug in x into g of x and then that into f of x, the way we write it is like this. We have f parentheses g of x, or f of g of x. Right. Now when we have our formulas below, this will make more sense, but I'm going to go ahead and write it down now. What it's telling us to do here is plug in the formula for g of x into x and f of x. Because whatever goes inside the parentheses is what goes in place of x, and inside the parentheses we have g of x. Right, but now we'll go ahead and work problems with actual functions and formulas. That way it'll make more sense. Right, and we're going to have a few here dealing with the same two functions. This first one says let f of x equal 2x squared plus x, and g of x equals negative 3x minus 5. So the first one here we want to do is f of g of x. So the first thing I like to do is just rewrite it immediately as f parentheses g of x. Because that's going to tell you what to do more than the circle notation. Now what I'm going to do is exactly what I wrote above. The inside, the g of x, I'm going to plug in the formula for g of x. Inside the box. I'm not going to do anything with the f, so I'm going to have f in parentheses, but then I'm going to have my new, well, not the new, but the formula for g of x written, which is negative 3x minus 5. So what we've done here, took g of x, the formula for it, and we plugged it right in the inside. Now, even though this is a new idea, this is just something similar to what we've done before. What this is telling us to do is now, everywhere we see x in f of x, we put negative 3x minus 5. In f of x. Alright, so let's go ahead and do that. Our f of x is 2x squared plus x. In place of x, we got negative 3x minus 5. And it's always a good idea just to use parentheses around what you're plugging in for x, whether it's a number or a formula. Then we got plus x, and x is negative 3x minus 5. Right. Now that we have, really this is our answer, but it's not simplified, and you definitely need to simplify. what we want to do is basically we want to get rid of all the parentheses and then combine like terms after that. Now what we have here in front, how we want to simplify this, we can't do anything with the 2 as far as distributing because of the exponent here. We have to take care of the exponent first. If the exponent wasn't there, then we can just distribute the 2, but we do have an exponent there. So what we're going to do is remember, squaring something means multiply it by itself. So I have negative 3x minus 5 times negative 3x minus 5. Leave the 2 out front. And then for the second part here, there's no exponent, there's no numbers in front, so you can just get rid of the parentheses, minus 3x minus 5. It's like distributing a 1 through. All right, now once we're here, then it kind of looks like you have a couple options. What I would recommend doing is FOIL this out first. FOIL first and then distribute. You're less likely to make a mistake. Because there is a way to distribute it, but you still have to FOIL it anyway, and you may distribute it incorrectly. It's not uncommon to do that. All right, so what I like to do, leave the 2 out front, make a big parentheses where we're going to put the whole thing we FOIL inside. So negative 3x times negative 3x is positive 9x squared. Negative 3x times negative 5 is positive 15x. Negative 5 times negative 3x is positive 15x. And negative 5 times negative 5 is positive 25. So we FOILed it, we left the 2 out front, bring down the rest, negative 3x minus 5. And now that the exponent is gone on the outside, we can distribute. All right, there's going to be exponents inside, that's all right. But the exponent on the outside is gone. Right. So you can kind of do this 2 ways. You can distribute to all 4, or you could recognize that 15x plus 15x is 30x, and then do the 2. I'm just going to do it in 2 separate steps to make sure nothing looks like it's skipped in the notes. So distribute the 2 to all 4 things. 2 times 9x squared is 18x squared, plus 2 times 15x is 30x, plus 2 times 15x is 30x, plus 2 times 25 is 50. Now once again, just bringing down the minus 3x minus 5. Now that we've gotten rid of all the parentheses, there's nothing to distribute. The last thing to do before we are done is to combine like terms. Once you combine like terms, you are absolutely done. You don't have to do anything else. So we got only one x squared term with 18x squared. Then our x terms, we have 30x plus 30x is 60x, minus 3x is 57x. And finally, 50 minus 5 is positive 45. So this is our function. Now this, once again, this is very similar to something we did previously, except we kind of started here. We are told what to do. Now we have this new notation. But as long as you switch it and plug in, it's the same question. Right, so the next part flips the order. It says, now do g of f of x. Whenever you flip the order, it changes the answer 99% of the time. You do not want to try to just write the same answer. Okay, so this time g is on the outside, f is the thing touching x, so it's rewritten is g of f of x. Once again, I can't recommend enough. when you see this, just rewrite it and then plug in the formula for the inside. The inside now is f of x. So maybe I should clarify that. The reason we're plugging in for the inside is because that's what we see. The f is, in this problem, the g is not next to the x, the f is. So we're always plugging into the inside first. And so we got g on the outside, we got parentheses, and in place of f of x inside, we've got 2x squared plus x. Now this can look a little more challenging than the first one, but I'll tell you right now that this one won't be nearly as bad. What we want to do is plug in this 2x squared plus x for x in g of x. And g of x is negative 3x minus 5. So we got negative 3. What we're plugging in for x is 2x squared plus x, and then minus 5. And maybe you can see right now that this one is going to work out a lot easier because our exponent, we don't have an exponent on the outside, so we can go ahead and just distribute the minus 3 through. Right. So the thing we're plugging in looks a little more complicated, but the way it works out is a lot quicker. All we do is distribute this negative 3 through. Negative 3 to the 2x squared gives us negative 6x squared. Negative 3 times x is negative 3x. And then bring down the minus 5. And you can actually see we have no common terms here. There's an x squared, there's one with x, there's one without x. So this is our final answer. No common terms, like terms to combine. Right, so the last one I have here is f of x. Basically, I think the first time you do this, on most of the problems you'll see f of g or g of f, but you can do the same function with itself. And there's nothing different about how you do the problem. So we start by rewriting it. We have f of x. F of x is 2x squared plus x, so we plug that in on the inside. We get f of, and then 2x squared plus x. Right, and so everywhere we see x in f of x, 2x squared plus x, we plug in 2x squared plus x. Right, it sounds kind of weird, but it's not that bad at all. So we have 2 in place of x. We got 2x squared plus x squared, 2x squared plus x, and in place of x, we're plugging in 2x squared plus x. Now this one's going to work out the same exactly as the first one because we're going to have to FOIL this out, write out the distribution or multiplication exponent, and then distribute the two, and then combine our like terms. I'll just kind of write that comment in. So it's going to work out like the first one because of the exponent on the outside. All right, so let's go ahead and do that. So we got 2, and then we got 2x squared plus x times 2x squared plus x. Just like the first one, we don't have anything to actually distribute. We're really distributing a 1 So you can get rid of the parentheses at the end. Now we FOIL the thing and leave the 2 out front. We got our 2 out front. We're going to FOIL it. 2x squared times 2x squared is 4x to the 4th, plus 2x squared times x is 2x cubed, plus x times 2x squared is 2x cubed, plus x times x is x squared. And then we're going to add the thing on at the end, the 2x squared plus x. Now we can distribute the 2 because the exponent on the outside is gone. Well, let me keep that to make it easier to read. So 2 times 4x to the 4th is 8x to the 4th, plus 2 times 2x cubed is 4x cubed, plus 2 times 2x cubed is 4x cubed, plus 2 times x squared is 2x squared. Then we bring the 2x squared plus x along with it. And then we combine our like terms just like last time. We get 8x to the 4th plus 4x cubed, and 4x cubed gives us 8x cubed. And then 2x squared plus 2x squared gives us 4x squared. And then we got plus x. And that is our final answer. And of course, you can do the same thing with g. You can have g of x, and that would be fine. Right, so the other thing when it comes to function composition is you can have, instead of the letter x inside here, we can have numbers. And that makes sense because the function composition, when we do that, we still get a function out. But it's actually a lot easier to not necessarily figure out the formula and then plug in a number. It's easier to plug in as you go. So we'll see with a couple examples that we have here. Right, so number 1, we have let f of x equals 3x squared plus 7x plus 4, and g of x equals 1/2 x plus 1. And we want to figure out f of g of 2. Just because there's a number here doesn't mean I'm going to start any differently. I'm going to rewrite. So it's f of g of 2. Right, and now here's where it really becomes different, is when you plug the inside in, well, you can actually figure out what number that's going to be. You don't need a formula because there's not an x anymore. You're going to plug in 2 into g of x, right? Because what that's telling us, plug in x equals 2 to g of x. So we got 1/2 times 2 plus 1. 1/2 times 2 is 1. And we get 1 plus 1 is 2. So what we're going to do is replace g of 2 on the inside with 2. We still have the f on the outside. But now in place of g of x, we have, g of 2, we have 2. And now once you're here, this is another type of the same problem. You have to figure out f of 2, but that's just telling us plug in 2 for x and f of x, just like we did in the previous sections. Even though we're in this particular section, it seems like the problem should be very different. It's really just doing two of the problems from before. So we take our f of x and we plug in 2. Everywhere we see x, we got 3 times 2 squared plus 7 times 2 plus 4. And once we simplify that number, that is our answer. The 2 squared is 4. 7 times 2 is 14. 3 times 4 is 12. We got 12 plus 14 times plus 4 is 18. And 12 plus 18 is 30. And that is our answer. So you will get a number out. When the inside is a number, the output is a number. Right. So the next one is just one with fractions to kind of deal with it. You know, it could be a little messier with a fraction, but the idea is the exact same. So part 2, we have g of f of 2/3. Well, we want to do the same thing we've done with all the other problems and immediately rewrite it. We got g of f of 2/3. And we want to do what we did last time. Oops. Scrolled a little too far. We want to figure out f of 2/3. We want to figure out the inside, what number that is, and then plug that in and whatever our result is for g of x. Okay, so let's go ahead and do that. F of 2/3. We got 3 times 2/3 squared plus 7 times 2/3 plus 4. Right, and because of the fractions, this will probably take a little more time than the other, but we square the thing first. We got 2 squared is 4 over 3 squared, which is 9, plus 7 times 2/3. If you write 7 as 7 over 1 and make it multiplication, 7 times 2 is 14 over 1 times 3 is 3 plus 4. And you can simplify it before you try to find a common denominator because we have 3 and up on top here, which cancels out with the 9. We can take a 3 out of each. And we get 4 over 3 plus 14 over 3 plus 4. Now to simplify this, we want a common denominator. We already have the same denominator in these two parts, so we got to get a common denominator here, denominator 3. And all we have to do for that is multiply the 4 by 3 over 3. And then add them all together. So we got 4 over 3 plus 14 over 3. When we multiply 4 by 3 over 3, 4 times 3 is 12 over 3. And then we add all the numerators together. And we get 4 plus 14 is 18, plus 12 is 30. So we get 30 over 3. And maybe we just got lucky. This might not always simplify to a whole number, but it simplifies to 10. Right, so that's really going to be most of the work in this problem because of the fraction, but it came out pretty easily. So we want to replace f of 2/3 with 10 because that's what it equals. On the inside, so we got g of 10. And now let me scroll back up. Our formula for g of x is 1/2 x plus 1, and we plug in x equals 10. All right, so we got 1/2 times 10 is 5, and 5 plus 1 is 6. So the final answer for this one is 6. All right, now the next one is, it looks similar. We have formulas, we want to plug in a number, but this one always can be a little confusing if you've never seen it before or just not comfortable with it. So it says let f of x equals 3x plus 5 and g of x equals 9. And we want to do a couple function compositions. This one's already rewritten for us. Some of them are, some of them aren't. But one thing I want to point out here, this is where the main mistakes are on these problems, is what g of x equals 9 means. When a function equals a number, then what it's telling you is no matter what you plug in for x, the output is a number, that number. So what this is saying is no matter what x value is plugged into g of x, the output is always 9. So what I typically find here is that if there's not a letter there, people just want to multiply by that number. Meaning if you did g of 2, some would say that's 18, but it's 9. It's always 9, no matter what x value. I could plug in 0 for x, and the output is 9. Right, so with that, it actually makes this problem very short. Right, the first one, f of g of 6. We do the inside first, just like before. And g of 6, like we just mentioned, no matter what we plug into x for g of x, we get 9. And we're gonna plug that inside. We got f of 9. Replace the inside g of 6 with 9. And now we want to plug in 9 for x in f of x. So we get 3 times 9 plus 5. 3 times 9 is 27, plus 5 is 32. And that's it for that one. The next one, it's the opposite order. We have f inside and g outside. But we still want to do the same thing. We want to do the inside first, figure out what that is. F of 4 equals 3 times 4 plus 5. 3 times 4 is 12, plus 5 is 17. And now we plug that in, the inside. We got g of 17. And just like in the previous problem, doesn't matter what we plug into x for g of x, because the output is always 9. Our answer here is 9. In fact, if g is on the outside, it doesn't matter what the inside is. We're going to get 9 no matter what. But just do the problem out. It's good practice. All right, so there's one more question before we get to the last part of this section. It's function composition with 3 functions. If you follow the rules outlined, doing the inside and working your way out, it's just one more step. And this one, because it would be really messy to try to simplify, you won't need to simplify your answer. So what we're given f of x equals x squared plus 2, or sorry, x to the 5th plus 2, g of x equals x minus 4, and h of x equals the square root of x. And the question is, what is f of g of h of x? Well, I want to do exactly the same thing I've done with all the other problems, and that's rewrite it. It can look a little messy with 3 things, but what you want to do is focus on the h of x, the inside part, the most inside part. And do the same thing we did before. So h of x, our formula for h of x is square root of x, and that's what we're going to plug in. Right, there's not a number here. We're back to the problems before. So we have f parentheses g parentheses, and now in place of h of x, we put the square root of x. So we, kind of think about it before. We did the g of x, the inside part. Now what do? Is we keep working to the outside. But the next inside part is this. We want to plug in square root of x for x in g of x, and that's what's going to go in our box. Right, so g of x equals x minus 4. The g of the square root of x, plugging in square root of x for x, we get the square root of x minus 4. Yeah, one thing I guess we can be careful about is that we're just replacing x with the square root of x, so the minus 4 is not inside the square root. Only x is inside the square root. Right, but that's what we want to plug in for g of square root of x. We got f of, in place of g of square root of x, we got the square root of x minus 4. Right, and from before we would have been done, we had 2 steps to do. This one we just have 3 steps, and we just continue. Now we have only f, and on the inside of our parentheses is the square root of x minus 4. So our last and final thing to do is plug in square root of x minus 4 for x in f of x. And this one we can do directly. We don't have to do it on the side because it's our last thing. So f of x is x to the 5th plus 2. In place of x, we have the square root of x minus 4. That's being raised to the 5th power. And then we have plus 2. And so x to the 5th plus 2, replacing x with the square root of x minus 4. And this is the reason you don't want to simplify that, is trying to do something to the 5th power out is very, very messy. If it was just 2, it wouldn't be terrible, but 5 takes a long time. So if you have 3, you won't see more than 3, but if you had 4 or 5 or 6, you just had, keep doing one more step, like we did here. Right, so the last section here is determining 2 functions that have a given composition. Right, for this last section, we will figure out how to determine 2 functions that have a given function composition. We will begin by looking at problems and describing what we do as we go through, because it's kind of hard to explain with beforehand, like before. The directions here say, for the following, determine non-trivial functions f of x and g of x, such that f of g of x equals what is given. Right. So the non-trivial function part is not meant to scare you. What this means is you cannot use just f of x equals x or g of x equals x. Which, if you follow the directions here, you will not ever use that anyway. Right, so the idea with this, we want f of g of x for the first one equals 6 over x plus 6 cubed. Now, really what we've been doing is thinking about the inside being what we plug in for x on the right side. So the g of x is the inside. So really what I want you to think about is if you had to call something the inside over here, what would that be? Well, anytime you have an exponent, a good idea for the inside is going to be what's being raised to the exponent. So what you want to do is make g of x equal x plus 6 in this problem. Kind of thinking the inside on the left equals the inside on the right. And that's half our answer. So how do we get f of x now? Once you decide g of x, since f of x is on the outside, we'll do g of x first, every time. To get f of x, or the outside, replace the insides on both sides with x. All right, so what I mean here is on the inside on the left is our g of x. We're going to put x. That'll make f of x. And on the right side here, our inside we chose to be x plus 6, but that's what we chose it for a good reason. So this is also going to be x. But when we do that, our left side of our formula is just f of x. And the right side is 6 over, and now this is just x to the third power. And that's it for f of x. Because we actually have what f of x is over here, since we replaced it with the same thing on both sides, it works out. All right, so it's sort of like, you know, with algebraic things, if we're doing stuff to an equation, as long as we do the same thing to both sides, it's okay. Well, here we're doing the same thing to both sides, so it's okay. And you can check your answer. I'll do it for this first one. This is not necessary. But if you take the f of x and g of x we got, f of g of x, we chose the inside g of x to be x plus 6. And if we plug that in, then f of x plus 6, we replace x in f of x with x plus 6, and we get 6 over x plus 6 cubed, which is exactly what it needs to be. So this is correct. Now there are ways to get different combinations of answers, but I don't recommend doing any different way. The reason is, the one time you might use this is for those of you that go to calculus, and this is exactly what you would need for those problems. If you chose g of x and f of x to be anything else, even if it's right in this question, it won't work the other way. So that's why we want to focus on looking at the inside of the exponents. All right, so number 2 is pretty much the same. You just have to realize that radicals are exponents. So we want to set the insides equal. And already note here that radicals are exponents in disguise. If you're not super familiar with that or remember that, that's because if you have, let's say, the nth root of x to the n power, because you might have an exponent inside as well, then this becomes a fraction exponent. The top numerator of the exponent is the power inside, and the denominator of the exponent is the number on the radical. All right, but we really don't need that for this problem. Just to mention that it's still the inside of a an exponent. So set the insides equal. We got g of x on the inside over here and the inside on the right. Well, since this whole thing is an exponent, I want to use the entire fraction here. So we got g of x equals x plus 3 over x plus 8. Right? So that is going to be our g of x, and then we replace the insides with x to get f of x. So on the left we have f of x because this is becoming x, and on the right side we have the fifth root, but the entire inside becomes just x. And you don't need to rearrange that, change it to an exponent, you can leave it as a radical. So our pair of answers here for number 2, f of x equals the fifth root of x, g of x equals x plus 3 over x plus 8.